Now we'll talk about curves in linear groups. So let's say that G is a linear group, and recall that this means that G is just a subgroup of the group of n by n matrices, invertible n by n matrices, either with real or complex entries. Then we say, we define a smooth curve in G to be a smooth function, that means a C infinity function, defined in some open interval in R, taking values in G for all t in the open interval. So you have some open interval like this, and then you have your group G, which I don't know how you visualize this, but say something like this, and then it takes this interval into G. So the image is going to be some curve like that. Okay. Now, when you have something like this, we're actually interested not in all smooth curves per se, but we're interested in smooth curves C in G with the property that C of 0 is equal to 1. So, for example, you could define C of t to be cosine t, negative sine t 0, sine t, cosine t 0, 0, 0, 1 in G, which is SO3. Right? This is a element of this special orthogonal group, the rotation matrices. So the thing to note is that for each t, you get a matrix in G. Okay, so this is our curve. And we can take the derivative, C prime of t. Notice that C of 0 is equal to the identity matrix. Okay, well, C prime of t is just defined to be the matrix whose entries are the individual derivatives. So you get negative sine t, negative cosine t, 0, cosine t, negative sine t, 0, 0, 0, 0. And if you evaluate this at 0, you get 0, negative 1, 0, 1, 0, 0, 0, 0, 0. Right? Now this matrix is not invertible. Okay. And we can actually take all smooth curves that satisfy C of 0 is the identity matrix and look at all of these matrices that you get as C prime of 0. And that's written as this Gothic G. So this is defined to be the collection of all matrices of the form C prime of 0, where C, here we're going from R to G, is a smooth curve with C of 0 equals 1, 1 being the identity in G. And we'll take a look at the structure of this collection of matrices in a future video.